All right. Good morning, everybody. Welcome to the CH-47 academic world. Well, Tom introduced himself a while ago and welcomed you. I'd like to be the second one to introduce you. Hopefully after today, you'll feel like you really made a good decision in getting in the CH-47. It's a great aircraft. You're going to notice our instructors, we all love the aircraft. We emphasize it. And we're really glad to have you here, and we're lucky to have you here. Some of the first things we're going to do this morning, I'll introduce the staff. Mr. Wayne Cook, he's our resident expert. He was our IP on the flight line for about 22 years, and he's been teaching this course for about 18 to 20 years. Mr. John Scott, he's one of our academic instructors. He's away right now learning the F-model Chinook so that we can come back and start teaching that when it comes on board. He's also the big proponent for that student handout, that little one you got in front of you there. He has worked very hard and redoing that for us. Mr. Borneman, you've met. He'll be your instructor. He and I will teach this course for the next month to you guys since Mr. Scott's gone, and Mr. Cook teaches the IPC course. And again, I'm Larry Cook. Our OIC is CW2 Bruce Snyder. He's also a rated aviator, but we keep him out of the classroom. Our phone number here, in case anybody needs to call us, 255-2555. That's not a misprint. If you have a cell phone and it's in another state, the area code here is 334, so it'd be 334-255-2555. That is the phones in our office. If you're going to be late, got any questions, even once you leave here, 10 years from now, you call that number back here, we'll answer any questions we can for you. If there is no one in the office and you need to get in touch with somebody here real early in the morning and something comes up and you can't be here, the dispatch phone downstairs is a little guy in a cage. We keep him locked up there. They're here from 4:30 in the morning to 11 o'clock at nighttime. Also, that dispatch, throughout the course, there's going to be things that you're going to want Xeroxed. There's a Xerox machine down there. I want to introduce our website, www.chinookdoctor.com. What you have in front of you, our student handout, is on this website. There is an emergency trainer on that website that will help you get through, like your 5 to 9 test. It will help you study your emergency procedures. You click on it, master caution panel will come up, and it will do it random. One of the caution lights will come on, you think about it, click it again, and then it will give you the procedures that you should have went through. Another website is chinook-helicopter.com. There's a lot of good information on there. I know who all you are now. I'd like to get each and every one of you, maybe if you have met each other, just stand up real quick, tell me who you are, where you're coming from, and where you may be going to, and why you are in Chinooks. Starting with you, Mr. Wellington. You don't have to stand up, just tell me who you are.
Jeff Wellington was a longbow instructor pilot, flown Apaches for the last 11 years. Decided to go back to where I grew up as an enlisted soldier, back to the TF, and pretty much do what they ask you, so I'm in Chinooks.
Well, welcome aboard. You're going to find out that I'm sure that video that we were showing while everybody was coming in, Chinook is a pretty maneuverable aircraft too, a lot like the Apache. Yes, sir.
Mr. Kevin Keith from Kentucky National Guard. Been flying Blackhawks for about 5 years, and it's rumored that we're supposed to get Chinooks in about 1.5 years, so they're sending some of us down here to get trained up this year. Been working on Chinook for about 8 years at Civilian World. Really looking forward to flying.
Well, again, welcome aboard, and anything that you can throw in here that we might need to be putting out, let us know.
I'm sure you guys have it covered.
Yes, sir.
My name's Damian Calvert, previous 60 pilot, 2 years. About the same unit Mr. Wellington is, so they said, you know, 547, said sure, why not? And that's about it.
You two are my task force gentlemen, aren't you? Okay. Yes, sir.
Paul Bus, come from Holland, going to be a flight engineer.
Well, welcome. Hope we can teach you a few things, and any input we get from you guys will help us a lot. Yes, sir.
My name is Marco Dekkers. I'm also a flight engineer. I got some training over here.
Okay.
That's all.
My name is Peter Dambacher. I'm also with Ron. I'm a Zach Morris. And we've been flying some fixed wing about 50 hours in Netherlands for training with the IER course here.
Welcome aboard. Yes, sir.
Kerry Native from the U.S. Grew up flying Black Hawk. Just finished up the Navy at this pilot school. I'm going to ATTC.
That'll be a lot of fun. I'm sure it will. Yes, sir.
Unedited, also from the Royal Netherlands Air Force. I've just finished flight school, the IRW. I'm looking forward for this.
Okay. What version of the helicopter do y'all have over there? The Diva? Okay.
I'm Marcus Stomphorst, also from the Royal Netherlands Air Force.
Welcome.
Just finished flight school, and I'm really looking forward to fly the big boy.
Well, hopefully we will sell you on this. A lot of our critiques come back that we've got the best Chinook salesman in the world with Tom Borneman. He really will get you enthused, I hope. Since the introductions are done, before I go into all our little rules and regulations and we start the class, I think I got a short video I need to show you. And then we will move on from there.
The Boeing Chinook is the world's most efficient, reliable, and versatile heavy-lift helicopter. It routinely does what other helicopters cannot. The Chinook flies with larger and heavier loads in demanding conditions that keep other helicopters on the ground. The secret is in the Chinook's tandem rotor design, with its efficient size and system capabilities that can move more payload faster at a more economical rate than any other rotorcraft, even in high elevations, turbulent winds, and hot and humid climates. With its stabilizing sling load system that utilizes up to 3 external hooks, the Boeing Chinook may move a vast array of large and awkward loads to critical locations at airspeeds up to 130 knots. A digitized cockpit management system, vibration reduction technology, and extended range fuel systems enable crews to fly complex missions with ease. Additional features that allow for water landing, operation in desert environments, and search and rescue extend the Chinook's already long list of mission capabilities. Long a mainstay of the United States Army, with a fleet of more than 400 CH-47s, Chinooks also serve more than a dozen other international military forces as their transport helicopter of choice. The Chinook is also a lifesaver in civil disasters, handling relief missions in floods, hurricanes, fires, earthquakes, avalanches, and snowstorms, over 4 decades on 6 continents. In the United States, the Army National Guard conducts civil relief, humanitarian, and environmental support missions across the country. Guard units from 10 states operate Chinooks to handle everything from engineering tasks to rescues. These missions often extend beyond state boundaries, making the Chinook a national asset. In the mid-1990s, television news viewers watched a Chinook lift needed equipment into the flood-ravaged Des Moines, Iowa water plant to return that vital facility to operation for 250,000 residents. Chinooks from California rescued stranded mountain climbers on Mount Whitney, an event documented on the TV show Rescue 911. 3 cross-country skiers stranded by an avalanche near Aspen, Colorado, owe their lives to a Chinook crew. No one else could have reached the skiers and saved them from brutal cold and sure death. A Pennsylvania Chinook lifted a bridge into a state park, saving wetlands from damage by trucks. Throughout a winter night in 1996, when no one else could fly, 4 Pennsylvania Chinooks flew in sub-freezing temperatures and blinding snow, completing heroic rescue missions to save 65 people from raging winter floodwaters that devastated small towns near Wilkes-Barre, Pennsylvania. Halfway across the globe, the flooding Sava River stymied U.S. Army engineers tasked with building a pontoon bridge for NATO peacekeeping forces moving to Bosnia. The engineers called for help from 4 Army Chinooks, which completed the longest pontoon bridge assembly since World War II in just 2 days. Through a record-breaking fire season in 2000, commercial and National Guard Chinooks fought dozens of blazes throughout the U.S., dropping millions of gallons of water and retardant. A Chinook can drop up to 3,000 gallons of water or retardant mix, more than most fixed-wing aircraft, with pinpoint accuracy even in 45-knot crosswinds on the deadliest infernos, and return with another load in minutes, unlike converted prop-driven bombers, seaplanes, and transports that may spend valuable hours returning to staging areas many miles from the fire line to refill their water tanks. Chinooks perform life-saving missions lifting food, water, and building supplies into Miami, Florida after Hurricane Andrew, when storm devastation made roads impassable and survivors might have starved. The U.S. Army's lifting capabilities are not, however, limited to emergencies in the United States. U.S. Army Chinooks carried tons of food, water, medicine, and clothing to save thousands of lives after Hurricane Mitch devastated several nations in Central America. Although other military forces have far smaller Chinook fleets, they also utilize their aircraft across a full civil mission spectrum. Chinooks facilitate U.S. and international force combined arms operations by carrying everything from beams to bullets, including missiles and fuel for rearming and replenishment, to keep combat assets near the front lines and ready to fight. The Chinook's ability to refuel other combat platforms keeps operational tempo high, making the CH-47 a genuine force multiplier for military services fortunate enough to utilize them. Military Chinooks from several nations successfully completed strategically important missions in Operation Desert Storm, continuing a long heritage of service extending from the Vietnam War. Kurdish refugees fleeing Iraqi suppression after the war would have died in the barren mountains between their homeland and Turkey without the lifeline provided by Chinooks from the United States Army, Britain's Royal Air Force, and the Spanish Army. More recently, British Chinooks participated in a record-breaking 3,000-mile flight from England to Sierra Leone, where they transported civilians out of danger during the Civil War and carried soldiers for a surprise hostage rescue mission. Throughout this assignment, the Chinooks performed flawlessly while transporting hundreds of people away from the ravages of war. Today, Chinooks of the Royal Netherlands Air Force are performing similar missions for the United Nations in Eritrea, a district of Ethiopia where civil war also rages. Despite the arduous climate and primitive conditions, the Dutch Chinooks are performing well, supporting United Nations forces in a variety of important peacekeeping missions. The Chinook is a lifesaver, but it's also a builder. CH-47s routinely carry large towers into the wilderness to extend power lines in remote areas. Commercial Chinooks lift tons of logs from forests for paper and timber mills, flying up to 2,500 hours each year to avoid ecological damage to surrounding forests. As one Chinook pilot said, "It seems like the more you use Chinooks, the better they fly. It's hard to realize just how much the Chinooks can do until you actually see them in operation." These examples just begin to tell the Chinook story. Nearly every day, the Chinook is serving on missions like these and more. The Boeing CH-47 International Chinook routinely does what others cannot, so that the only limit to its mission capability is the user's imagination.
That was just one of our nice little short videos we've got. If I failed to mention it before, there are only two types of helicopters in the United States Army inventory. Y'all know what they are? Have you heard what they are? Probably not going to like to hear this, but it's only Chinooks and sling loads. We are the only ones that can really carry ourselves. But once, hopefully y'all all feel that way when you get through with this course. Before I get into the meat and potatoes of this and we get into our student handout, we got to go over some of the little rules and regulations and tell you where a few things are here. We've already welcomed you. We've introduced the staff, the facilities, the good hand. Parking, student parking, should be across the street in front of the building in that big parking lot area. Should there have an event and it gets full, then we can bleed over into the side over here or in the back. Just be cautious. If you park on the grass, they will tow your vehicles away. Brake areas. For the CH-47 or everybody here in good hand, there's not really a designated brake area. What we do when we have a break between our classes is we kind of congregate down here to the end of the hallway. The coffee pot's down there. We try to be a little bit quiet in case there's other classes going on. Coffee down there, since we've mentioned that, it's 25 cents a cup or $1 a day. We try to keep it made as much as possible. If it is empty, notify one of the instructors and we'll go down there and we'll make a couple of pots real quick. Smoking area. If you got to smoke, there has not really a designated area here around Good Hand. You just got to be 50 feet away from the building. Bathrooms, the facilities down the hallway. Take a left, you'll see the elevator, and then another immediate left next to the water fountain is the male latrines. And then there's one on either end of the building downstairs. Learning Center. Anybody not know where the Learning Center is at? The Learning Center. Okay, you know where the PX is at? Our PX, the exchange? On that 5th Avenue, I believe it's what's called. Okay, 5th Avenue. A couple of buildings back this way, there's a place called SACS, S-A-C-S. And incorporated in that building is our Learning Center. They have videotapes, they have study material. If you miss a class, you can go over there and look at it. If we have a test failure that we'll talk about after a while, you're required to go over there, spend a little bit of time. But we're in the CH-47 community, we're lucky. One of the gentlemen that is over there is another Mr. Snyder, not our Bruce Snyder that we have here, but a civilian, Snyder. He is an X-47 pilot. So in the afternoon, if you feel like you've fallen behind either here in academics or on the flight line, Mr. Snyder's over there, he's available, he can answer any of the questions that you have for you. Telephone use, make sure I don't have mine with me. Cell phones, it's just become a fact of life. If it does go off in the classroom, please immediately try to hit it down to cut it off, but try to put them on vibrate when you come in here. We understand that a few people are important. I know one of our task force gentlemen in our last class, a major, was still a commander back in Fort Lewis. He had a few phone calls. Those things happen. Just let us know that you're expecting a call so we'll be aware and nobody gets upset. Food in the classrooms. As long as we do not let it get nasty in here, food in the classrooms is okay. You're going to notice as you get to flying out on the flight line, AQC class that's in-house right now. They're supposed to be here at 1 o'clock in the afternoon to start class. They've been showing up at 1:15 because we've got to get as much flight time as we can. We allow food in the classrooms, no problem. If you don't have time between the flight line and getting up here to class to stop at McDonald's or Hardee's, wherever you need to stop, inside our TH-67 cockpit area over here. Everybody familiar where that's at? If you're not familiar, I will show you during break. In the back side of that classroom, in the back corner, there's a refrigerator, a little coffee fund they call the Creek Cafe. There's burritos, there's little breakfast sandwiches, pizzas that you can microwave if you need to grab something to eat between classes or in the flight line. Restrooms that we've already showed you where they're at. Fire drills. Good Hand Simulator building is notorious for fire alarms going off. If the power flickers, we're fixing to start getting into a thunderstorm time of the year around here. If the power flickers, you can set your watch to it. 20 minutes later, the fire alarms are going to go off. What we do is we meet out to the front of the building. There's a tree. We meet underneath that tree. Class commander will get a head count. We will wait out there till they tell us all is clear, and we'll come back inside. POI. In front of you, you have our student handout. For the next 23 training days, we're going to cover everything that's in there. That is a good reference to keep in the future. There was a theory of operations manual out when the D model came out in 1984. We have taken, it was full of pictures. We've taken a lot of those pictures out, put a lot more information in there. This should be something that you should reference many years from now. We keep it updated on ChinookDoctor.com, the website we told you about before. If you'll go on there, you'll notice that each one of these lessons in here are posted. If there is an update, it will say new. You print it out, put it inside there. If you have a color printer at home and you don't mind using up the ink, the student handout on that website is also in color. If you can pull it out in color, those pictures, along with the text that's in there, make a lot more sense. So we got 23 training days. We're going to have you for about a month. We're going to cover 19 subjects. We've got a lot of training aids. We've got a few in the classroom right now. We've got a lot that we'll drag in and out as classes go through. Be cautious of our training aids. I mean, they're here for you to look at, for you to study, to ask questions about, but be cautious. We have a lot of cutaways. They may be sharp edges on them. They may be heavy. Try not to get injured on them, please. Dash 10s. Everybody got dash 10s? Got your changes posted? Should be dash 10 with change 1. We'll try not to say too much about the dash 10. There's a lot of errors in it. It's embarrassing. Chinook's been out for over 20 years. Dash 10 came out in June, and there's still a lot of errors in it. If you find anything wrong with our student handout or the dash 10, let us know. We'll get the changes made and hopefully get the system, put them back in the system so everybody will have that change. The dash 10 you need to bring with you every day if you can. Anybody bought the mini dash 10? Okay, that's probably a good thing. Once you leave here, the mini dash 10 is good to have, but once you leave here, you got to realize that when changes come out, you're going to be responsible for shrinking them, laminating them, put them in there. But for the days that we have weight and balance, PPC, you're going to need to have your large dash 10 with you anyway because of the charts that are in there. I have a hard time reading the charts in the large dash 10, much less a mini dash 10. The exams. Most of your Army examinations that you've ever had so far have been multiple guess. Our exam, this is our answer sheet, will be fill in the blank, 50 questions. We're not here to make it hard for anyone. We have found out, and we've got back a lot of response on critiques, that they've enjoyed this fill in the blank a lot better. It gives us a little bit of latitude. If you can write out an answer that's not verbatim what we're looking for, but can give us an idea that you know what's going on or where a component is and how it works, I've got the latitude to say, yes, they know what's going on. Or I could pull you back inside, ask you a little bit more, and if you really do have an understanding, I can let it go. But again, fill in the blank. You'll notice at the end of each one of our lessons that we go through, there's a practical exercise. If you go through each one of our lessons and do those practical exercises, there will not be any surprises on our exams. It's not to say that they're the same questions, because they're not, but they will lead you in the right area. We will have 3 tests. Training day 8 will be our first exam. All of our tests are 90 minutes long. Training day 8, first exam, will take you 90 minutes. It will include PPC. PPC for the Chinook is huge. It will probably take you an hour to do those 8 questions. But the PPC portion of the exam number 1 Once you do the first 42 questions, we will take your answer sheet or that portion of the test back from you, and then you can use all your notes. You can use your -10, you can use your student handout, you can use the ATM to get through that portion. But we want to make sure that everyone has an understanding of how to do PPC when you leave here. Each exam is broken down into scorable units. Each lesson that we teach today, introduction, there will be a portion of the test. You've got to pass each portion of the test to pass the test overall, just like any of the other Army examinations you've taken up until now. If you fail any portion of the test or the exam, then we will do our counseling. We'll go see Mr. Snyder. We keep the first one in-house. We will retrain you, give you 6 hours of retraining, and then we will retest you just on the portion that you failed. Should we fail the second time, then we have to go across the street and see our boss's boss. That one we cannot keep in-house. And we will go from there, the guidance on how bad it was done or how comfortable you felt with the instructors. Maybe something was wrong and we weren't putting it across appropriately. Maybe a language barrier. But we will get it done. We have not had a problem with failures in the past. We've had a few on the first time, but usually after the first time we can get them through. We're not here to try to belittle anybody. We want everybody to pass and be the best you can be. We want everybody to be, in the Chinook world, we all want to be good. We want to be recognized, and we want you to be recognized. So we've got our -10. One of the things that we have done for everyone here, if you want it, on a CD, on a DVD, it's gotten big now, a DVD. We have taken and we've put our student handout on the DVD. All our PowerPoint presentations are on the DVD. There's a place in Pennsylvania called EATS. It's the Pennsylvania Guard. They are responsible for training a lot of the Guard pilots. They have a disc of training. It's not really PowerPoint, but theirs has audio on it. You can go through the courses. It really lines up somewhat with our student handout because they use our student handout. You can look at their slides, press audio, and it will tell you a little bit about what's on those pictures. So then again, there we go. We got the student handout, our PowerPoint presentations, the EATS disc, the videos. Some of you got in here early enough. We were showing some videos. We've put some videos on there. And then at the end of the course, you'll get PFPS amps. Y'all won't get PFPS, your AQC, so we can give you the PPC portion, the automated PPC. Keep in mind now, the Chinook world is the only one right now that does not say, okay, we can use the automated. We are doing, for PPC, we're doing it hand jamming. But there is the automated system out there. Use it to check and balance each other. But all those are on the disc. They'll cost $1 for anybody that wants one. We're trying to recoup. The Army doesn't buy the DVDs. We buy the DVDs and the sleeves and cases that they go in. We're just trying to recoup our money for those. And end of course critique. We really, really, really want your input, whether it's negative or it's positive. It may not help you, but it will help the people that come after you. When we get to the portion of engines, hopefully they finished them up today. Today's the 28th of February. The people 3 months ago were complaining about our engine. This is a 712 engine. We have 714s on our aircraft now. It got put into a critique, and our colonels read them. We've been trying for a year to get those engines over here, but once it got put into a critique, Colonel saw it, action was taken. And again, anything, if it's negative or positive, if our instructors are doing bad, if I'm doing bad, we're thick-skinned. We want you to be the best you can be. So start taking notes now through the end of the class, and we'll ask for a critique at the end of the class. Are there any questions before we get started into the meat of the program? All right then. In your student handout, page number 5, somewhere close by there. And you can see now everybody's going to need to have a 3-inch binder to put that in. If you decide that it's a large book and you want to break it apart, look out on our board out there. We've got our class schedule. Break it into 3 parts. Break it down into everything that's covered in the first exam, everything that's covered in the second exam, everything that's covered in the third exam. Because we have to be flexible with that schedule that's out there. We have sometimes 3 or 4 classes going on. There's only 4 instructors available at any given time. The max we have are 4, and we may have to rearrange a class. So if you break your student handout down, break it down into the 3 sections. Today's terminal learning objective: describe the general operational characteristics, systems, and limitations of the CH-47 Delta. I am going to go through with the slides today, introduce the aircraft to you, talk a little bit about the systems, and each system that we're going to talk about today we will go in depth in as we go through the course. It's going to be in the classroom. We've given you your student handout. Now here's the big one, the standard. Correctly answer in writing without reference 5 of 7 questions pertaining to the general operational characteristics and limitations of the CH-47 Delta helicopter in accordance with the -10 in your student handout. So in our first exam, there'll be 7 questions, and you've got to get 5 of them correct to get a go on this portion. Safety requirements are none. We are not going to pass around any of our training aids today. Risk assessment's low. Environmental considerations are none. Environmental considerations, when we do start passing around some of our training aids, they have come out of aircraft. Some of them have been here for 10 years, and you can move some of these parts and oil will still come out of them. Evaluation. Again, on our first exam, training day number 8, you'll be evaluated on this during our first exam, and you've got to get a go on this unit. You'll have 90 minutes to take the test. Models. Anybody got any idea how many different models of the CH-47 we've got in the U.S. Army inventory right now? We got a bunch, thanks to Task Force. We are migrating to the F model, but the Task Force has always had the special ones. We'll go through some of them. Right now here at Fort Rucker and a lot of throughout the Army, we have the CH-47 Delta model. That's what the cockpit looks like on the inside. As we get through this, I'll show you some of the differences and how to tell you what engines. I mean, we've got the CH-47 Delta out there, but we've got 712 engines here, and we've got 714 engines. That master caution panel right there will be my dead giveaway of which set of engines I've got. With the 3 columns there, it tells me I've got 712s. Once we go to the 714 engines, they did an MWO, and we've got 4 columns and added some more lights. Task Force. These are the big guys. They have the MH-47 Delta, Echo, and Golf. This is what their cockpit looks like. A lot more to what we're going through with the F model. Be aware, the gentlemen that just come out of the Apache, this is nothing to you. I understand that. But for the new guys, when you get into this new cockpit, be aware that one of you needs to be looking inside here and seeing what's going on, and at least one set of eyes need to be on the outside. It's too easy for everybody to look at this new equipment on the inside and forget where you're flying and fly into something. Unfortunately, we had that happen last June. Somebody coming from Savannah, Georgia, come to a graduation here at Fort Rucker, and a G-model Chinook with all this high-speed equipment flew into a tower. It's new, it's nice. And here's what we're going to, the F model. And there's the cockpit for the F model. It's a lot, this is an artist, it's been doctored up a little bit so you can have all the colors there. But this is where we're going. Some of you will have the opportunity to come back once we start doing the differences course here and you start flying the F model. Some of you will have the opportunity to come back and go through that. Cairns has an F model now for anybody that has the opportunity to go out there. It's kind of hard to get to. If you know somebody, you might be able to go out there and look at it. Has anybody taken the time? I know the AQC, you've been around aviation for a while. Have you seen the A model in the museum? If you haven't seen it, take the opportunity to go over there and just look on the inside. And I'll talk a little bit about that more in a minute. LSA number 1. Describe the general operational characteristics, configurations, and limitations of the CH-47 helicopter. Rotor dimensions. These are numbers that we're not throwing out there to ask you to remember. These are numbers that I want to throw out there to you because of the aircraft that you just came from. The Apache, it's a little bit longer and a little bit bigger than I realized it was when I walked up on one the other day. Those people that have been flying the CH-67 and the OH-58. And the Black Hawk. Look at the rotor dimensions that we've got now. 98 feet, 10.7 inches. 60 feet wide. You've got to find a bigger parking spot. You've got to find a larger confined area to go into now. It is a tandem rotor system, 3-bladed counter-rotating rotor system. Rotor heads are going to turn the opposite. Always remember that the rotor system is going to turn into the left side. If anybody ever asks you which way the forward rotor head turns or the aft rotor head turns, it's always going to rotate into the left-hand side of the aircraft. Some of the other dimensions, and these are some that I really want to point out because they are very important. The 7 feet 8 inches when it's static, it actually droops a little bit lower than that when the rotors are not turning. When the rotors are turning, it can drop down to 4.4 inches. That's very important, very, very important, because I don't care how often you brief your passengers before you go pick them up. You tell them that their ramp is our primary means of entrance. A lot of times you're going to notice that a crew member is going to drop that front cabin door on the right-hand side, and people see that door and they want to rush up there and get in because they want to sit up front. If they're coming from the front part of the aircraft, that rotor system, 4.4 inches, can dip down that far. It's not conducive. Rotor blades and bodies do not mix. 18 feet 11 inches in the back. With the rotors turning, 16 feet 1 inch static. That becomes important because you've got to get up on top of this aircraft in pre-flight. And I'm going to tell you from experience, a lot of things I'm going to tell you from experience during this class, things that you don't want to happen. That's a long fall. There are work platforms above the engines right there that we lower down so that we can climb up and look on the rotor head. You've got to be careful. Remember where you're at and do not step off one of those. I've shown you these dimensions. I've talked about people walking into the rotor blades. Unfortunately, it has happened only once that we know of in the CH-47 community. And would you believe which rotor system, can you guess which rotor system that it was that hit them? You would think that it would be the front, but we had a blade strike with an individual with the aft rotor system. Come out of Fort Lewis, Washington a few years ago. Pilots landed close to a hillside, lowered the ramp. Troops went out running up the hill. Pop, they got him. Be aware of where you park, where your crew member or where your passengers have got to get in and out. A big, big aircraft. Some more of the dimensions. From wheelbase, our wheelbase is 22 feet 6 inches. You should have the opportunity while you're here to go out and do pinnacle landings. I'll talk about that again in a little while, our crew members, but a little bit about them. We have the enlisted crew in the back. We've got the pilots up front. We've been doing this for a long time. As a crew, we work well together. I'll guarantee you when the crew member is calling you down on that pinnacle, trust him that he's making sure that both those wheels are going to hit. He wants you to land safely on that pinnacle as much as you want to be there. Your slopes, your crew members can see those wheels with our bubbled windows, and they're going to put you down there safely. Component locations. Again, this is a large aircraft, big, huge. A lot of parts, so that means a lot of times we get a lot of write-ups. To make it easier for people to find these things, even when you're out there on the flight line doing talk with your IPs, to make it easier to identify the components, where they're at, we've broken it down into a couple of different things. Everything on the left side of the aircraft will be number 1. And when I talk about these systems here in a moment, you'll see that our electrical system on one side is number 1 system. Everything on the right side is number 2. If it's on top, we consider if one component's on top of another component. 9 out of 10 times. There are some exceptions, and we'll point those out in the class. The component that's on top will be number 1. The component that's on bottom will be number 2. So now we've talked left side, right side, top and bottom, and then front and back. Our flight control system broken down into 2 systems. Number up front in the forward pylon area will be number 1 flight control system. And the back area will be number 2. Makes it easier to identify the components, makes it easier for us to write things up. Any questions about anything so far? Fuselage stations. Anyone here remember what a station is? What's a station number? Anybody gone through weight and balance before? Station numbers are numbers that we've identified as being in front of the aircraft approximately 21.5 inches or 21.5 inches. 2 inches in front of our PDOT tube is station 0. That is inch 0. For every inch back towards the back of the aircraft, that will be a station number. So if we stock station numbers, it's inches back from our imaginary, we call it a reference datum, in front of the aircraft. Some of the major component or major areas that we're going to be concerned with, from station 21.5 to station 95, for you gentlemen, that's home sweet home. That's the cockpit. For most of you, that's home. That's the cockpit. That's where you're going to be at, but you're also going to be responsible for everything all the way back to station 630.5. From station 95 to station 120, we call that our companionway. When you walk into the aircraft on the right-hand side, and to get into home sweet home at station 95, you've got to go through the companionway. When you walk into the companionway in the middle of the aircraft, facing the front of the aircraft, on your left-hand side will be what we call the flight control closet. And we will spend a lot of time in the flight control closet with Mr. Borneman. A little bit farther on the other side of the flight control closet will be the avionics compartment. On the right-hand side of the aircraft will be our heater compartment. And that's all between station 95 and station 120. Between station 120 and 160 is the entranceway to the aircraft. On the right-hand side of the aircraft, there is a cabin door that drops down that you can walk in. Also, station 160, when you get inside the aircraft and you look on the floor, you'll see a red line. We will not pull any cargo any further up than that red line at station 160. From station 160 to 486 is the cabin area. Station 249 will be underneath, will be the center, or the forward cargo hook. Station 331 will be our center cargo hook. Station 409, aft cargo hook. And then station 486, when you walk out on the aircraft for the first time and you start pre-flighting, you'll notice that the ramp hinges. That is where the cabin area stops, station 486. One of the main formers that runs around where that hinge is at, that's where the cabin area ends. And then from 486 to 630 is the ramp area. And then our engines, T55GA 714 Alpha engines. I've mentioned it briefly a little bit here at Fort Rucker, out here on the flight line. Unfortunately, we are the last ones to get some of the MWOs done. We have 712 engines on some of the aircraft, 714s on some of the others. You really won't know what engine or aircraft you're going to fly until that morning when they issue them out, and it's only so many to go each way. Hopefully most of the time you will fly 714s. That is primarily what we will teach throughout this course, is 714 engines. You still will be responsible. One stick buddy will do 714 PPC, one stick buddy will do 712s. That way you're ready to go when they throw an aircraft at you. You'll find out when we talk about our engines in a moment. We've got power for days. At 50,000 pounds, which is our max gross weight, we lose an engine, we can still maintain flight. Looking at this picture right here, what engine is that one right there? Number 2. All right, that's pretty much standard on most aircraft. This aircraft's designed to fly during day, night, VMC, IMC, and water operations. And I'm here to tell you, if you ever get the opportunity to put one of these things in the water, do it. It is fun. That used to be part of your graduation here. Become too cost ineffective, and we stopped putting them there. Minimum crew. Here at Fort Rucker should be the only time you ever fly with 3 people, unless you take the opportunity and you go with your test pilots in your units, which is a good thing to do and learn things from them. But most of the time we fly with 4 people on board. There are occasions, I think task forces started flying a lot of times with 5 people on board, 3 crew members in the back. Korea, when we flew MBGs, we put an extra set of eyes in the back. But most of the time, you will fly with 4, a minimum of 3. Never fly without 3. We do work well together. We are a crew. We try to not, the enlisted should keep their respect, but we try to keep the integrity of the crew, and we work well together. We need each other. Maximum gross weight of this aircraft, 50,000 pounds. With the crew of 4, and a full bag of gas, the aircraft approximately weighs 31,000 pounds. And then that leaves us 19,000 pounds for cargo. And then you will learn a little later on how to trade off the fuel for the more cargo if you need it. Again, this is our fuselage section. We were talking about our stations earlier. Just shows in this picture here how it's broken down. It's a semi-monocoque structure. Cockpit section, cabin section, ramp section, and then we've had to add the aft pylon section because of the way our rotor systems operate in tandem. We put an aft vertical shaft up there, but it is divided into 4 sections. Cockpit section, cabin section, ramp section, and aft pylon section. Are there any questions of anything up till now? All right. Are there any questions about anything we've covered up till so far? I know we haven't covered a lot. Components that are on top, or which components? Number 1. Good job. All right, we're going to get into emergency equipment. When we start throwing these slides up here, we're not in here trying to scare anybody. We want to emphasize that the emergency procedures in this aircraft, there are several of them. They are important. They are there for a reason. Unfortunately, the individual that was flying this one in the desert had a couple of lights come on, didn't really pay that much attention, or can't say he didn't pay attention. It got confusing. They ran out of gas. So, not a good thing. Some of the emergency equipment that we have in this aircraft, we have 3 fire extinguishers. There is one located in the cockpit on the pilot's side, the right-hand side. There is one located at station 120 above the avionics closet. And then there is one in the back, station 486, in the ramp that the flight engineer will use a lot of times when we start our APU. These fire extinguishers are not to fight large fires or fuel fires. They are for personal use. If the aircraft catches on fire, get everybody out of the aircraft, and if you grab those fire extinguishers and somebody's on fire, fight that individual. Do not try to fight the aircraft fire. This aircraft's a lot of magnesium in it. It's going to go quick. We can replace the aircraft. We can't replace individuals. Troop alarm and jump lights. Again, station 120 above the avionics closet next to that fire extinguisher. There will be a red-green light with a troop bell. Back station 575 on the left-hand side, in the ramp area, there will be another set of jump lights. They use these primarily when we have our paratroopers on board. Red light means stay seated, green light means go. The bell, believe it or not, with all the noise, both engines running, all 5 transmissions turning, rotors popping in the air, that bell can be heard. Use this bell during ditching procedures. 3 short bursts prior to impact. You go to one long burst and let it go. It should let everybody know what's happening so they can brace themselves in the back. First aid kits. There are a total of 7 throughout the aircraft. The first one that y'all from the cockpit will be concerned about grabbing on your way out will be one in the companionway, and then there's 3 on either side scattered throughout the back of the aircraft. These first aid kits are for their emergency equipment. They will only be used in the event of emergency. During pre-flight, there's a lot of safety wire and Carter keys and sharp objects on this aircraft. If you cut your finger and you start bleeding, do not open up one of these first aid kits, because then when you crash and somebody needs it and it's not there, that's on you, not them. You have a survival vest. You injure yourself during pre-flight, you need to use something, use it out of your survival vest. When you turn it back into ALSI, tell them that you used it. These are to be used during an emergency. As these things are opened up, they are inspectable. They've got inspection dates on them. If I open up one and put it back up there, I've just restricted the aircraft to 7 less passengers. For each first aid kit that's used and becomes unusable, I can carry only 7 less passengers. Emergency escape acts. In the unfortunate event that we have to cut ourselves out of the aircraft, we have an emergency escape axe. It's located at station 200 on the right-hand side. When you walk inside the cabin door up front on the right-hand side, first 3-man troop seat to your immediately left, behind the soundproofing, will be this emergency escape axe. When you pre-flight and it's on the checklist, just look to make sure it's there. You do not have to pick it up, look at it, and inspect it. Just make sure that it's there. It's a piece of steel that's not going anywhere. If you pull it out, you stand the chance of dropping it, breaking a toe, or putting a hole in the aircraft floor. Emergency exit lights. These lights are designed to illuminate in the event you have a hard landing of 3 Gs or more. And at nighttime, they give you a valuable asset of being able to tell you where the exits are on the aircraft. When I walk into the companionway or the cabin entrance on the right-hand side, immediately on top of that door will be an emergency exit light. Right across the cabin area on the other side, there will be a panel. And there will be a light above the top of it. And then in the back, the ramp area by the auxiliary power unit, there will be another light. Again, when we have a hard impact, these lights will illuminate and show us the exits. They can also be used, even if they don't illuminate when the 3 Gs. If I've got to escape out of the aircraft and it's nighttime and I can't find a flashlight, I can reach up, I can pull it out and open it. As long as that red handle's pulled open, it will be used as a flashlight. Again, this is emergency equipment. Don't think that I'm going to the field at nighttime. I've got to pull that light out so I can go use the bathroom somewhere. Emergency equipment. If you use it then, it may not be available when you really do need it. Cargo compartment. Any questions about the emergency equipment?
Are those standalone, those lights, or can you activate the cockpit at all? The emergency lights?
You can activate them from the cockpit. You can arm them, disarm them. And that's one of the things you're going to have to work out with the checklist, because if they're not properly turned off with the checklist and you leave them armed and the battery's plugged in, it will drain our battery down because it's constantly recharging those batteries that are on the inside of it. It's a good question. Cargo compartment. This aircraft, again, when we talked about our rotor dimensions earlier, this aircraft is huge. Everyone should know what a Humvee is by now. The military's got them, and you can see those huge ones rolling down the highways and the civilian version. We can put 2 of those in the back of this aircraft. It's huge. Not much room left on the inside when we pull them in there, but there is a lot of room. It's 90 inches wide, 78 inches tall, and 366 inches of usable cabin area in the back. When I say usable, that's from station 160 back to 486. Or 120 back to 486. We usually don't pull anything above the red line if it has weight on it, but the cabin area does extend 366 inches.
Is that a CG thing, or is that a structural integrity thing in the floor?
It's a structural integrity, and that's about what we're fixing to talk about here. As far as not being able to go past Station 160, the areas that are on my slide that are marked in red is a treadway area. If we pull wheeled vehicles in here, that's where we try to put them. And underneath that part of the floor right there from Station 160 back, there's vibration absorbers underneath the bottom of it. It strengthens the floor a little bit more than the rest of the floor. And having those vibration absorbers that are in there, you keep the vibration from the load transferring to the aircraft, or from the aircraft to the load and things bouncing around in the back. CG problems with this aircraft, when we do weight and balance, you'll understand that CG is not a real big problem with this aircraft until we start putting things on the bottom. We can, in those areas, uniform distributed loads, we can put those out throughout the aircraft. We've got water lines and butt lines. As you become seasoned aviators and you need to know what those water lines and butt lines are, it's in your -10. When we put loads in the floor, we are not to exceed 300 pounds per square foot. I haven't seen very many loads that do exceed that. When you come back, once we all aspire to be PICs and IPs and all that, when you come back for IPC, we'll talk about shoring. Does anybody have an idea what shoring is? Mr. Wellington does. Shoring is nothing more than when I do exceed this 300 pounds per square foot, that I can take plywood and spread that load out a little bit farther to reinforce it. Passenger configuration. We can carry 33 troops. So that consists of, in the back of the aircraft, we have 10 3-man seats and 3 1-man seats. So we can carry 33 troops and put them in, seat belt them safely in the aircraft. There is one seat in the companionway, the troop commander's seat. We can also put the troop commander in there. That would be a place that while your stick buddy's flying, when you're here in school, that you are going to be sitting. I want to give a little bit of caution about the troop commander's seat on how it works. The reason that I do this is that one of our class commanders 3 or 4 classes ago unfortunately thought that seat was locked up, got ready to crawl over it, and it fell through. And our center console is up a little bit higher than the companionway floor, probably about this much higher. When his knees hit the floor, his face hit the center console. One time you can say, okay, that's an accident. It knocked him out, or pretty much knocked him silly. They wouldn't let him fly for a couple of days. When they let him fly again, he tried it again, and he did it again. What happens to this troop commander's seat is it folds down, it's hinged on one side. There is a handle in the front of it. You pick this troop commander's seat up, it's supposed to lock in on some formers on the flight control side of the companionway. You push down on it, and a lot of people make sure it's locked and they crawl over it. Again, I said that we are a crew of 4 most of the time. Use that crew member in the back. You just say, Chief, I need to sit in the seat. You stand in the companionway, he pulls the seat up, locks it, you just sit down. Be careful. I mean, it's just something that happens. And if you want to do it on your own, before you crawl over it, make sure that it's locked very well. We can pull our seats up without having to pull them out to bring our cargo like our Humvees on the inside. We can carry litters inside the aircraft. And unfortunately, in the time that we're living in right now, some of you will have to go to the desert and do this mission. We can carry 6 tiers, a total of 24 litters inside the aircraft. There may be times where we need to mix litters and cargo, or litters and passengers. When we do that, the litters need to go to the back side of the aircraft, passengers go to the front side of the aircraft. Why do you think we'd want to do that? We want to get the littered patients out faster, and we can use those troops that we put up front as they exit the aircraft to grab the litters and take them out. Extended range fuel system, IRFs 2. Task force, guys, you're going to see a lot of these. These are the crash-worthy fuel systems. You'll see that when we go through our fuel class, we'll show you the old IRFs 1. In your Dash 10, it referenced IRFs 1. IRFs 1s were 600-gallon metal tanks. Again, non-crash worthy. We have taken these now. They put 3 of them on the inside. All 3 of them will hold 800 gallons of fuel apiece. So now we've added 2,400 more gallons of gas to the 1,034 gallons that we've already, so you can stay in the air for a long time. Also, besides using it for ourselves, we have what we call the fat cow system, so that we can go to a field site, set up, and we can refuel the other aircraft. But we will talk about this in great length when we go through our fuel class. There is a burn sequence on this. Now this one we do have to worry about CG with all that weight on the inside. When I'm using my IRFs tanks and I'm burning them, I must burn the number 3 tank, which will be the aft tank first, and then I go back up and burn number 1 and then number 2. HICS, Helicopter Internal Cargo Handling System. And no, this is not my neighbors down here in the south, my next door neighbor, the Hicks. This is a great system. I crewed this aircraft many, many years ago, and we didn't have this. This is designed to be put inside the aircraft and for us to use the 463L pallets. For those of the people who do not know what a 463L pallet is, it's the ones that the Air Force use, the aluminum pallets, so that most of the time we can grab those loads. Those loads are already strapped to those pallets. We can roll them inside the aircraft, and we can lock them to this roller system, and we can take off and we can go. So it saves time with loading, and it's just a lot easier. We point this out now. We will go through this during cargo handling class, but we point this out now because some of the aircraft out here on the flight line that you are going to be flying during this course has the HICS system installed. Be cautious when you walk around in the aircraft. Another thing to be aware of and caution of is you can trip over these very easily. We do not use them here, but they are installed. Fort Rucker is a big reset. Now that the war's going on, aircraft get wore out, they bring them here, we rebuild them, and we give them one of the ones that we've got. Normal, emergency, and rescue entrances and exits. Now we'll start talking about some numbers here in a moment. Emergency exits, like on all of our windows, there is a yellow tab. All of the windows that are in the aircraft are an emergency exit. You pull on the yellow tab, it will pull out an inner liner around that rubber ring, and you just push the window out of the way. Same goes with the window that's in this big panel and with the panel itself. It also has a yellow pull tab. When you got somebody as big as I am, they can't fit through that little window, you push that big panel out and they should be able to get through. This panel is on the left side of the aircraft. When you walk in from the right side through the cabin entrance there, this is the one that's right straight across. On the inside of the aircraft, that second emergency exit light that I talked about will be on just right above that panel. Those are your emergency exits. Also in the cockpit, your doors are jettisonable. You'll have handles in the cockpit. You'll pull on them and they'll fall away. The cargo loading and ramp area, it is also an emergency exit. A ramp is operated hydraulically. It comes up hydraulically. We'll talk about this during our utility hydraulics class. We use hydraulic pressure to bring it up, but it free falls down. So you have to be aware of that in a couple instances. If you're going to put it in the water and you want to lower your ramp, you got to lower your ramp before you put it in the water. But this, again, is an emergency exit. It's where we use our primary entry and exit of the aircraft, and it can be used as an emergency exit. On the ramp, we have that 300 pounds per square foot limit that we have to be concerned with. But on the ramp, we've also got to be aware that in a total area of the ramp, we cannot exceed 3,000 pounds. Inside the ramp, it's hard to see in this picture that we have here. There is a door, but a lot of the times you will not see closed. I don't think you'll ever see it closed here at Fort Rucker. When the ramp comes up, about 4 to 6 inches from getting to the up position, it will stop. This ramp door will shoot out, and then the ramp will come up and it will seal. You'll hear me and probably Tom refer to it as we go through this class as the ramp tongue, but it's called the ramp cargo door. It also has some escape panels on it. There will be a little yellow panel instead of a window in the middle of it, a yellow panel with a pull tab. You can pull it out and push that panel out. Also, on the bottom of that tongue when it comes out, there will be a big yellow handle. If that little panel is not big enough for me, I can pull on that yellow handle. If I'm right side up, the door will fall away. If I'm upside down, I can pull that handle, then I'm going to have to push the door away. But it is an emergency exit. Our main cabin entrance door up front, it's broken down into 2 sections. The height, 66 inches, you really don't have to worry about that because you're stepping up and into the aircraft. You shouldn't be bumping your head. It's used as, it says normal exit and emergency exit. Again, try to brief whenever you pick up passengers. Do not come in from the front side of the aircraft. If they think they can start coming in up here as your rotors are turning up front, it could lead to an accident. The upper portion of the door. Now I'm going to be talking about some numbers here for a little while. Opening and closing this door in flight can be tricky. That upper door is on a set of rollers on each side. When it's fully open, it's locked to the rear. You get flying, especially at altitude, it starts getting cool. You tell the chief, or the chief wants to tell you, hey, I need to close it because it's getting cool in the back. You need to slow down below 100 knots. Because if I'm above 100 knots, I've released the lock, I start lowering that door. When it gets about this close to being shut, a Venturi effect's going to take place. And it's going to pull the door this way. And it's not going to stop. Been there, done that. Dropped one in the middle of a parade field one time when I did that. It's going to hit that, and it's just going to pull it on through. Fortunately, my door went down, but it can go up and go through the rotor system. So we must slow down to 100 knots before closing that door. I would even slow down a little bit further. Play it on the safe side. The lower door, the restriction. To fly with this door down, or to even lower it in flight, I don't know why we would want to be doing that, but to fly with it down, you cannot exceed 60 knots, and it must be locked down. Once the door is lowered down, there is a little lock mechanism here on the side. Pull up on the back side of it, push it forward, and it will lock it down. There will be a case that you may have to fly with it down. There are many times where you're out flying, missions change. You've already loaded internally as full as you can get. My cargo utility hatch door is covered up with a pallet that weighs 4,000 pounds. Crew members can't move it. Now they've called you over the radio and said that they want you to pick up some fuel blivets. Well, normally the crew member lays in that cargo area to call a sling load. I have seen them, as long as we use the safety harness in the back, sit at this cabin door and call you in over a sling load, hook it up, and they'll monitor it in flight as best they can from that door area there. In Hawaii and in Norfolk, Virginia, the Navy has to film their ships every 6 months. They have to go around and take pictures of them to watch the corrosion. We have put photographers on those doors, but there are cases that you could fly with that door down. It says it can be configured for an M24 mount air machine gun. I point this out because, again, been there, done that. That machine gun mount, there will be a bar that goes right about where the upper cabin door stops. You get used to walking in and out of this aircraft as a crew member or as a pilot, just stepping up on that cabin door and pulling yourself in, and you go. Then all of a sudden they tell you you're going to go put a gun there and you're going to fly missions with that. If you forget that that gun mount's there, it hurts. I did it. We were in a field problem. We put it there, plugged the battery in, going to come back in and run in and crank the APU to raise the ramp. Forgot the door mount was there. Everybody had a laugh at my expense. We locked it up, we went and ate, come back. The pilot thought he'd go plug the battery in and he was going to crank the APU to crank the heater. After they had to laugh at my expense, I had to laugh at his expense. It wasn't 30 minutes later, he did it. So it's been done, it will be done again. Be cautious of it. And if they do enter from the aircraft, passengers are going to enter, make sure they come 90 degrees off the nose of the aircraft. All right, another limitation that we have to be aware of. So far, we've covered the upper cabin door restriction. Closing it was what? Less than 100 knots. Flying with the lower cabin door down was 60 knots. Now then, this door that is on the bottom of the aircraft, we have another limitation that we have to be concerned with, 90 knots. Anytime that this door is in transition, we cannot be exceeding 90 knots. I cannot think of a case other than that mission changes in flight and you want to get the cabin, that door open to lower the cargo door to, lower the cargo hook to do a sling load, or all of a sudden you decide you've got to land in the water, you store the hook and you close it. If you're doing it in flight, you've got to slow down below 90 knots or that door will leave the bottom of the aircraft. As long as it is fully open, there are some rubber mounts here on the front part of it. It will swing up a little bit farther and back up against the aircraft with those rubber mounts. As long as it's all the way open or all the way closed, there are no restrictions. But they have put a restriction in there about the 90 knots. It's one of the things to look for on pre-flight. Before you go out and fly, and if they've got this door open, which 90% of the time when you fly, make sure that those rubber mounts are up against the belly of the aircraft. Because if they're back 2 or 3 inches and you exceed this 90 knots, the strain on the motor, the gears will give away and that door will fall down and it will fall and leave the aircraft. Sternal cargo hooks. We've got 3 of them. As I go through this class, anytime I mention the center cargo hook, and I do not mention that it's the only one that operates off hydraulic, hit me in the head with something. Our forward and aft cargo hooks operate off electricity, and they operate manually. Our center cargo hook will be operated hydraulically. Center cargo hook, rated at 26,000 pounds. And again, we're going to airframe restrictions with this and the strength of the hook, because we can, with the engines that we've got on this aircraft, we can lift anything. It's mounted at station 331. There are 3 types of releases. First of all, normal release. We want to release it hydraulically if we can. If it cannot be released hydraulically, we would try to blow the air charge that's inside of it and we will release it pneumatically. If that fails to work, we have a manual release that releases all 3 hooks at one time. That will be our last resort of releasing the load. We'll break these down again when we go through the cargo hook class or the cargo handling class. But again, now I want to give you another one of my silly little cautions and little silly anecdotes. You're going to get used to walking inside the aircraft with that cargo utility hatch door closed. You're going to be walking around doing your pre-flights in the flight control closet. You're going to be doing it on the ramp. Then one day during stage 2, you're going to start going out and you're going to be doing loads. Then it's going to require you to start pre-flighting that hook. That little cargo utility hatch door is going to be open. Don't walk through it. And when I say don't walk through it, there'll be 2 or 3 of you that will accidentally, sometime in your career, walk through it. I've done it. Tom's done it. John's done it. And unfortunately, one of the guys that's in Flight School 21 right now was set back 3 months because he walked through it. Walked through it and his knee caught that beam, had stitches, and had to be put on medical hold for a while. It's just a safety factor. We get comfortable with things. That utility hatch door is not open, and then all of a sudden it is open and we don't even think about it. In my case, we were getting ready to go fly. I opened it up to do the cargo hook check, turned around to go start the APU first, and then I remembered I forgot something up front. Turned around and walked right through it. And I just opened the door. So not everybody forgets like I do that quick, but I was young then. Our forward and aft cargo hooks, rated at 17,000 pounds apiece. Located at Station 249 and Station 409. These are accessible by ground personnel only. When I start talking about loads in a moment, you will see that most of the time that we are flying with loads underneath the aircraft, we are going to try to do it tandem. Tandem meaning that we're going to have the slings hooked to our forward and our aft hooks. If we're going to do that, there has to be ground personnel. The only time you should probably be carrying anything on your center cargo hook nowadays is if we do not have access to ground personnel to hook it up to our forward and aft hook. The crew members here are fantastic. They can go out, you'll land next to a block here, they'll go out and rig the load while you are doing your free takeoff checks. They'll put the sling on top of the block, they'll call you over the load, they'll drop a shepherd's hook through the bottom of the aircraft, pull the sling up to them, put it on the hook, and you'll go. That will probably be the only time you'll ever do a center cargo hook, if you do not have any hookup personnel. Again, this one is not hydraulically. We've got electrical normal release, and then we've got it on another bus, electrical emergency release, and then again the same handle that releases the center cargo hook releases the forward and aft hook manually. Our load configurations, what I just got through talking about with our center hook, we will only carry this when we do not have access to hookup personnel. Tandem loads, maximum is 25,000 pounds. Remember, what did I say the forward and aft hooks were rated at? 17. We can't add that together and say 34. We have to be aware of the fact, and it happens occasionally, that one of those slings may break, and then it's going to swing forward. That 25,000 does exceed that 17,000 pounds, but it won't rip it out of the bottom of the aircraft. And then this is a configuration that has become very useful in the desert, carrying out shorties and supplies to different locations, different drop zones. I can pick up 3 different loads and drop them off at 3 different places. Being aware of the fact that I must pick up all 3 at the same place. They must be put together at the same place, but I can drop them off. When I figure my weight and balance, I can drop them off at different locations. It's worked very well, and it saves a lot of shorty missions from having to keep going back and forth and back and forth. If you were real good, you could probably pick them up in different locations, but you're going to have to set one right next to the other one and bring the cargo hook down, and it may throw you out of CG. Try to pick them all 3 up at the same place. Air-to-ground towing is prohibited. I'm sure some of you have seen the Discovery Channel when that little 406 just tried to pull a little ski boat. Didn't get very far. Evidently this guy made it, because I haven't seen any pictures on the internet where he crashed or anything, but that is prohibited. Do not try that. Water operations. When we go into the water, normal operations, we are limited to be at 36,000 pounds. Emergency rescue operations, we can go in the water at 46,000 pounds. Flotation time, 30 minutes max. That's with the rotors turning or without the rotors turning. I've got to pull it out of the water in 30 minutes. If I've got to be in any longer, I'll pull it up out of the water, let it drain, whatever little bit of water gets into the airframe, let it drain out, then put it back in. But I do not need to exceed that 30 minutes of flotation time. Both main tanks, and this goes for the main tanks only, must be at least 50% full. And you're going to find out when we start talking in our fuel system that our ox tanks are going to empty out or they're always feeding our main tanks. So once they're out, then we will start worrying about this 50% being full. The reason being, we're not worried about fuel getting mixed in with water. Our fuel cells on the outside, fiberglass shaped honeycomb material. On the inside of it are our fuel bladders, or our bags. Inside the main tanks, we have 3 fuel probes. We have 2 fuel pumps. there are several lines on the inside of that. Water is allowed to get in between the fuel cell and the fuel bladder. If that water gets in there and you are less than 50% full, that bladder starts to compress on the inside between the cell and the water, starts to push in on it. You'll start interfering with your boost pump operations. You could knock some lines loose on the inside, develop fuel leaks. So we must be at least 50% of fuel, full of fuel on the main tanks. Any questions about water operations? Center cargo hook carried how much weight, or maximum center cargo hook? 26,000 pounds. Water operations at nighttime. Yes, we can put it in the water at nighttime. I've never had the opportunity to do that. But we've got to meet some requirements. Both AFCS must be operational. Both radar altimeters must be operational. Must have a visible horizon, and must have 2 or more visually stationary objects in the water. LSA number 2. LSA number 1, you've talked about some of the emergency equipment. You talked about the cargo hooks. We talked about some of the dimensions on the rotors. Now then we'll get in and we'll start talking about the operational characteristics. Operational characteristics and limitations of the CH-47 Delta helicopter engines, transmissions, drivetrain, rotors, electrical, and an AFCS and the subsystems. Getting into all the little neat pieces of the aircraft. Master Caution Advisory Panel. If you remember back during the first slide when I showed you the Delta model cockpit, there were only 3 columns of lights. Now there are 4 columns if you have the 714 engines. It was a modification, a different modification. When they did the engines, they did this at the same time. We now have 64 lights, which consist of 38 caution, 6 advisory. They are placed on the master caution panel in what someone felt was the order of priority. And I would imagine all the aircraft are that way. Then we have our green lights on the bottom. They are advisory lights. Our hook open lights telling us that we've got external power hooked up. Park and brake and our APU on light. Maintenance panel in the back. What they've done when they went to the Delta model Chinook was they took all your hydraulic gauges out of the cockpit and we put them in the back. We've also given us some more indications in the back. Has anybody ever had a flicker and chip light that bothered the heck out of you? You never could figure out where it was at. Well, now then we've got something that helps us a little bit with that. We've got latch indicators. These little latch, black and white little indicators here, if I get a chip light on a number 1 engine, number 2 engine, or a transmission, if it flickers on the master caution panel in the front, this is going to latch and it's going to stay lit. So I don't have to go searching for that flickering or that big piece of chip that may be floating in a transmission anywhere. In the cockpit, on your gauges for the transmissions, you have, again, we've got 5 transmissions. You've got selector switches that can tell you which transmission oil pressure that I want to monitor at that time. But we go into the scan position. Scan is looking for the lowest or the highest pressure at that time. Once the master caution light illuminates, it's not going to tell you which transmission. I can take the time if I want to go through the selector switch, find out which one it is, and then initiate the emergency, or start initiating the emergency once that light comes on, but some of the emergencies are different. Or I can immediately ask the crew chief. I can tell him I've got a transmission oil pressure light. Which transmission is it? And he can go back there and tell you exactly which one it is. We've got filter change lights in the utility and flight control system. A lot of our components are up top. We can't monitor those in flight. When a filter button pops, it tells us it's becoming clogged. Now we've got an indication on the maintenance panel. Our hydraulic pumps, in the past, they were notorious for just quitting on us at inopportune times. The engineers, being the smart people that they are, they've designed them now that when we can almost tell you when they're going to fail. And I'll show you how, when we talk about our hydraulics classes, I'll show you how that's accomplished. But we've got pump fault lights. They'll come on when they feel that the pump's about to fail. They may fail in 5 minutes and they may fail in 5 years, but we have an indication now when a pump is going to fail. And then we have ground contact lights. That's telling you that the aft landing gear are on the ground, you're down and you're firm, and it will desynthesize the AFCS a little bit so that you don't get a lot of erroneous inputs from the wind or whatever from AFCS, some of the stuff that it does for you. Our engines, again, manufactured by Honeywell. They always have been Lycoming engines. Our engines over the years have never really changed from the design. We've just gotten more powerful and more powerful. Sometime within the next couple of weeks, Mr. Borneman will spend 6 hours with you and tell you all the neat things about this engine. But it's a free power turbine 2-stage engine. We can use JP8, JP4, JP5 without making any kind of changes at all. Our shaft horsepower. Now this is just per engine. And when we reach our 2.5 minute, 4,867 shaft horsepower, one engine. If we need to go into emergency power, we have the capability of 5,069 shaft horsepower. So in an emergency situation, we have over 10,000 shaft horsepower if we need it. Again, aircraft fully loaded at your limit of 50,000 pounds, we lose an engine, you have single engine capability. Contingency power on pilot demand. We'll talk about the engines a little bit more in a minute, but we've gone computerized with the 714s. They're used to it on the, I believe, the Blackhawk or the Apache has a DECU, aren't their engines computer controlled? We're just now getting to that. We'll talk about a FADAC system. It's a system, it's not a component. FADAC will consist of a DECU, nothing more than a little computer telling the engine how to operate, when to operate, and it monitors it for faults. And then we've got the HMU, which will be our electrical fuel control. A little cutaway of our engine on the inside. Blue indicates N1 and red should be N2. As you can see, as we suck air in for our N1 inlet turns one way, and then our N2 turns the opposite way. That counter-rotating keeps that engine from rolling off the side of the aircraft. But as we are producing power with our N2 section, it's free turbine, and then there is a shaft that rolls through the front portion of it up front. That's where we take our power we're producing out of the back, run it back through the inside of the engine, and it's mounted to our nose box transmission that we'll talk about in a moment in front of the aircraft, and then we distribute the power out a couple of different ways. And again, Mr. Borneman will give you a fine class on the engines, tell you all about them. Our engine control system, what I was alluding to a while ago, is called FADAC. Don't be asking anybody to see the FADAC. The FADAC is a system. It consists of a digital electronic control unit, a DECU, a hydromechanical metering assembly. That's our fuel control now. Again, all you have to do with this aircraft now is reach up there on the engine start switch. Once you're ready to start the engines, push it over to the number 1 side or the number 2 side, and that DECU takes charge for you. It will start all the start process for you, where you don't have to sit there and hold the motor button and watch for things. It monitors everything for you. It monitors PTIT as it's rising. If it gets too hot, it will shut things down. Our transmission and drivetrain system. Again, we've got 5 transmissions. First 2 transmissions that we're going to talk about are our engine nose box transmissions, or engine gearbox transmissions. They take the power from that N2 shaft running through the air, through the center of the engine, and they take it and turn it 90 degrees to our combining transmission. Inside of there is a sprag clutch. I'm sure everybody knows what a sprag clutch is by now. What does a sprag clutch allow us to do in most aircraft? Auto rotation. Now, a lot of people come through in the class that I have this afternoon, and I'll be in Flight School 21, they're coming from the single engine aircraft. and they get into that single engine mentality that, yeah, it's there for auto rotation. We have a little, with having 2 engines here, you're going to notice when you start going through our checklist, we have to start the number 2 engine or the number 1, we have to start our second engine within a time frame of starting our first engine. Because that sprag clutch, there is a little bit of friction in it, and as we start one engine, it carries over and it's turning some of the components inside the second engine, but it's not turning our oil pump. That's one of the things it does for it. But the auto rotation, I was getting off subject there again. It allows us for auto rotation. It prevents the rotor system from driving our engines. We always want to be able to drive the engines to drive the rotor system. But if we lose one of our engines, it allows that other engine to completely disengage from the system. It won't drag the rotor down. Combining transmission. This one is one of the most important transmissions that we've got. In the past, we were known as the only aircraft that could have a mid-air with itself. Over the last few years, they have developed this combining transmission, and they've taken a lot of the bad things out of it, and we haven't had any failures in a long, long time from the combining transmission. It takes the power from both engines, receiving it in on the side, and again, it distributes it another 90 degrees, forward and aft. On top of the combining transmission is a reservoir. This is where the oil will be stored for our nose box transmissions. Also on top of it are 3 coolers. The cooler for the combining transmission itself and the cooler for each engine transmission. I don't want to take anything away from Tom's class. I'm sure he will break it down and tell you a lot more for it. In a little while I may be talking, and in some of my classes, the aft pylon area here in the front part of the combining transmission, there are 2 cowlings that are on the front of it. If you hear myself or Mr. Borneman refer to clamshell doors, those are what we call the clamshell doors. Open them up and you can look inside. Because in the back side of the top part of that are some of the hydraulic components that I know that I will be talking about. Now we get into our drive shafting before we get into our forward and aft transmissions. There are 9 synchronizing drive shafts on this aircraft. 7 between the combining transmission and the forward transmission. And then there's 2 between the combining transmission and the aft transmission. We have 2 engine drive shafts, and then they all have adapters and the couplers assemblies. Again, we will break those down. One of the things that I want you to be aware of while you're here at Fort Rucker, you will be lucky if you get to pre-flight the top of this aircraft twice. You'll really be lucky if you get to pre-flight it once. But do not take it that it's any less important than anything else on top in the aircraft. You're going to see pictures when you go out to the flight line of a Pepsi can. It was found inside the drive shafting area here after a flight. The drive shafting area in this aircraft is very important. It will not take long for it to cut itself in half. When you pre-flight the top of this aircraft, look for FOD around those drive shafting. One other component that I want to point out that's not in your student handout at this point, that we'll talk about a little bit later on, the aft vertical shaft. It has transmission characteristics, but it is a drive shaft. It has oil pressure switch on it. It has a chip detector on it. It's a drive shaft. It's where we're taking our input from our aft transmission and turning our aft rotor system. And you really don't know where to classify it, either as a transmission or a shaft, but it falls in between them. Our forward transmission area. It provides our mounting for our upper controls, our upper dual boost actuators, our flight controls. And our number 1 flight boost pump will be located on the bottom of the forward transmission. Has our swash plate on it, and it's located in the forward crown. When you walk up to the top of the aircraft and you pre-flight it, you've got 2, we call it the doghouse cowling, but there's a door on either side. You can look inside and pre-flight it. And again, our number one flight boost pump is located on the forward transmission. That goes to that front and back thing that we talked about earlier. Aft transmission. few more components are located on the aft transmission than they were on the forward transmission. Our number 1 and number 2 main generators located on the aft transmission. Our number 2 flight boost pump is located on the aft transmission. And then our utility hydraulic pump is located on the aft transmission. And again, like I just mentioned a while ago, that aft vertical shaft fits down on top of the aft transmission to take that rotation from the aft transmission up. One of the things that we've got to be aware of, I told you on the forward transmission was mounted our number 1 flight boost pump. I told you on the aft transmission that his number 2 flight boost was located. That follows that rule that we talked about earlier, front and back. Now you're going to be out on the flight line and somebody's going to ask you, what pump is that? Well, if I was looking at that right side up, that pump is going to be on the number 2 side. But that's not my number 2 flight boost pump. That's my utility pump. The number 2 flight boost pump is on the number 1 side of the aft transmission. And trust me, people are going to try to trick you up with that. You're going to be on the number 2 side. You're going to be looking at the maintenance panel. We're going to be talking about a lot of utility hydraulics things. They're going to put their hand on your shoulder and they're going to turn you around to the number 1 side of the aircraft, talk about a few things. Going to turn around and they're going to look up and you're going to see a pump. You just got through talking about utility components. You're going to see a pump and you're going to say, oh, it's a utility pump. No. We're on the number 1 side of the aircraft right now. We're in the aft though, and it's the number 2 flight boost pump. Our rotor system, fully articulated. Our rotor blades are made of fiberglass. Each blade weighs 350 pounds. As we go through our flight control classes, you're going to find out that we have at least 4 pumps in our flight control system. Or, as a matter of fact, we got 4. Unlike the TH-67, OH-58, UH-1, OH-58 Alpha Charlie, I don't know about the Delta model, but the UH-1, if you lose your hydraulics, you can still fly those aircraft. If we lose the hydraulic system in this aircraft, you're not going to move the controls. If it weren't from going from mechanical to hydraulic back to mechanical to hydraulic, even if it was just straight mechanical, you would not be able to move the controls. How many rotor blades we got? 6. 350 pounds apiece, that's heavy. Each rotor system weighs anywhere from 400 to 600 pounds, or the rotor heads themselves, that's a lot of weight to move. But our rotor systems, again, fully articulated. What does fully articulated mean? It means that we control the pitch change, lead and lag, and the flap on our rotor system. Are there any questions on anything up to this point? All right, I've just looked at my student handout and it looks like there's a lot left. We're going to breeze through this. Again, these things you are going to get in-depth classes on. I just want to make sure that we get introduced to everything on the aircraft so that when you go out here and you start pre-flight and you have an idea of what you're looking at. Next thing on for bid here, on page 37, your student handout, is our auxiliary power unit, our APU. And I'll usually kid all my old 58 people about this being their engine. It's pretty close. Mounted at station 600, it is a single-stage centrifugal compressor type turbine. It drives a motor/pump. When I say motor/pump, mounted on the front of the APU is a utility hydraulic motor pump. I need it to be a motor when I start the APU, but just as soon as I get the APU online, it turns into a pump. It will be my utility hydraulic pressure until I get my transmissions turning. Once I get the transmissions turning, then I can cut my APU off and use my utility hydraulic pump. That means that it's a backup. If I lose that utility hydraulic pump, crank the APU up and I've got utility pressure again, hopefully. It's also got a third generator on the back. And we'll talk about our generators here in a little bit and talk about how good that generator really is. But think about it this way. I use this generator when I crank the aircraft. It runs fine. It operates everything perfectly. So those 2 generators I have mounted on the aft transmission, if they both fail in flight, I know I've got another backup there. There is redundancy in this aircraft. There's backup after backup after backup. So feel comfortable with it, the fact that when you start the aircraft, you are starting it with that generator. It is a backup aircraft, so don't panic when you get in the air and have a problem. We use it for the APU for ground operations and, like I said, for some in-flight emergencies. It also is going to be controlled with a little white box called an ESU, electronic sequencing unit, just like the engines were with a DECU. It controls the start. I hit the start switch, it goes through its sequences, it monitors the start for over temperature, pressures, and will shut it off any time that anything is wrong. Our electrical system, big electrical system. Now when we go through our electrical class towards the end of this course, it's kind of hard to prioritize which classes you teach first. You know, people holler at us and say, why are we teaching electrical at the end when everything we talk about is controlled by electricity? Well, PPC is important, flight controls are important, so this kind of falls towards the end. We're not going to make electrical engineers out of anyone. By the time you get to this portion, it's a 3-hour block of instructions. Tom will make you feel very comfortable about the electrical system in this aircraft. On the left-hand side of the aircraft will be my #1 system. And the electrical pod up front, in front of the fuel system, you will find that there will be a generator control unit in there for our #1 generator. And our battery is also located inside there, transformer rectifiers. But everything that's on the #1 side will be, or on the left side is #1. Our electrical panel in the cockpit, very simple panel. Battery switch, off, on. APU switch, that's where we start our APU, 3-position switch. And then we've got our 3 generators. Again, you guys come in AQC, you've flown these aircraft, you should know by now. This will be one of those panels they expect you to do it with your eyes closed and memorize. Our main generators, located on our aft transmission, 2 of them. They are 40 kVA generators. They are oil cooled. When you go through your transmission class, you'll find out where it gets its oils from. 2 of them, again, 40 kVA, oil cooled. Our next generator is the 20 kVA generator mounted on the APU. Charlie model and below, this was our generators. We had 2 of them mounted to the aft transmission. As you can see now, you've got power for days. We went from having 2 20 kVA generators and everything operating fine. Now we've given you 2 40 kVA generators, power for days again. We do not have a lot of electrical problems. But this is your backup. This one is not oil cooled, it'd be air cooled. Our DC system. Again, it's broken down in the left-hand, right-hand side, #1, #2 side. Transformer rectifiers. Purpose of a transformer rectifier is to do what? AC to DC. Again, we have AC generators in this aircraft. We need to convert it back to DC. Most everything in this aircraft is AC operated, but DC controlled. That's meaning I'm using my switches to open and close relays and let the AC power flow through. One of the things I want to warn you about with our transformer rectifiers, there's one on each side in the little compartments in front of the fuel cells. But on the inside of the aircraft, behind the first 3-man troop seat on the left side and the right side, and behind the soundproofing is a screen. We're coming out of the cold season, so most of the people do not wear their jackets on the flight line. But it is a big problem with people throwing their helmet bags behind the troop seats while you go fly. These fans, that's where they suck the air in to keep our transformer rectifiers cool. Do not store anything behind the front 2 seats on either side of the aircraft. Transformer rectifier gets hot, then you're going to need to know what your transformer rectifier emergency procedures are. Batteries. You're going to find out on the flight line. There are 2 different types of batteries. This is another conversion that should be going on. We got the pink batteries out there as the slab batteries, and then we got the blue batteries that are the NiCad batteries. When we are converting again from our 712s to 714s, they are doing the change out, taking the NiCad batteries out of the system. If I have a NiCad battery in the aircraft, also on the left-hand side in that #1 electrical compartment, there will be a battery charger. This was put in the Delta model Chinook to try to trickle charge the NiCad batteries because we were having a problem with thermal runaways. This was to help trickle charge it. It was to monitor it. And with the 712s, if you got a battery malfunction light on the caution panel, then you must know your emergency procedures, reset circuit breakers for the battery charger. But it monitors for over temperature in the battery, cell imbalance. And one of the things I want to caution everybody about, and I know I'm not talking bad about crew members, I talk back from past experience. Being on the flight line, you go out there in the morning, battery's dead because somebody left it plugged in all night long. The easiest thing to do is go to the aircraft next to you, pull their battery out, plug it in, start your APU, turn generator on, plug your battery back in and let it recharge. If I have a NICAD battery, that is a very bad thing to do, because that's when it tries to charge too quick and it can get into that thermal runaway. But I had an experience many years ago with a Charlie model. Fortunately, the pilots were out there that morning. Got ready to do the pre-flight, couldn't crank the APU because the battery was dead. Normally, I probably would have done the bad thing, jump-started it. But I went and got a new battery that morning. We were on our way to Fort Bragg, North Carolina. Halfway there, IFR, dual generator failure. And in a Charlie model, there was no backup generator. Had we not replaced the battery that morning, we would have all panicked. Because with an old battery, you do not know how long they're going to last. 1 minute, 30 minutes, whatever. But having a new battery in the aircraft, you felt comfortable. I got 20 to 30 minutes to get the aircraft on the ground. Do not let anybody jumpstart these batteries. In the field, in the desert, anywhere. It's an unsafe thing to do. External power. Now, I don't know, I haven't seen too many of them hooked up to the Black Hawk or the Apache, but the 58s, I saw them hook them up, CH-47, and start the aircraft. If you're going out to your aircraft in the morning, you've got your helmet bag and your flight vest thrown over your shoulder and you're walking out, you see that you've got an AGPU hooked up to your aircraft, just turn around and go back the other way. We do not need this for anything. I spent 21 years in aviation in Chinooks. I used it one time, and that was to convert from the old hydraulic fluid, non-fire resistant, to the fire resistant hydraulic fluid. It was easier to flush the system that way. But we do not use it. It can be used for AC power, DC power, or I can use it for hydraulic power to do any troubleshooting that I need to do with the aircraft. But we do not need it for anything else other than troubleshooting. And again, if it's there, your aircraft broke. Our fuel system. Again, we got 1,034 gallons. We've got 6 fuel cells. And you'll see in your student handout there, I believe it's got it broken down to how many gallons are each fuel cell. 2 forward aux, 2 aft aux, 2 main tanks. Our aux tanks always empty out into our main tanks. Our main tanks feed our engines. That is the only place that we have that the main tanks can draw, the engines can draw their fuel. The left side main tank will also feed the APU. The right side main tank will feed your heater. See, I don't think there's anything else you need to know about those. We'll talk about it again in depth later on. Task force, you gentlemen, you'll have to put up with the fuel class because you're only going to have 1 fuel cell on each side. Big fuel pods. Single point pressure refueling. This was a great thing when they came out with the D model Chinook. Beats over winging it. Remember many a days cold out there at Fort Campbell at Son DZ trying to refuel a Chinook just like you do your car. It would take 45 minutes and it gets cold after 45 minutes. But now supposedly we can refuel the aircraft in 4 minutes at 55 PSI. Remember the 55 PSI. Not for anything on the test here, not for anything on the flight line. Most Army stations were going to operate somewhere around 35 PSI. But if you do cross-country flights and you stop at a civilian airport, you stop at an Air Force base, be aware that their pressure may be higher than 55 PSI. If I try to refuel this aircraft any higher than 55 PSI, I will ruin the airframe of this aircraft. It will, once those bladders start overfilling, they're going to crush the stringers and the formers on the inside of the aircraft. Reality is, when you go out to Goldberg and you start refueling, it will probably take you anywhere from 8 to 14 minutes to refuel the aircraft at what we've got going right now. I can refuel my internal tanks, the earths, with a single point pressure refueling. Also, and then again, when I talked about the earths earlier, I can use those to run the aircraft. Stay in the air for a while. Any questions so far? Again, we're going to start running through this a little bit quicker. Try not to exceed our times here. Utility hydraulic system. This is one of my little pet peeves. I enjoy teaching this class. A lot of things work off of this. Once we get in the air, there's not really anything we use off the utility system. But my utility system, when we go through that class, it leads a lot into my flight control system. Our hydraulic reservoir, it's going to be located in the aft pylon area. Between the number 2 engine and the aft pylon, when you go out to pre-flight every day, there will be a panel opened up. Inside that panel, we call it the hydraulic panel, you'll see our utility reservoir on the right, immediately on the right-hand side. You'll see a number 2 flight boost reservoir in front of you and several other components. The reservoir is where we store and cool our fluid till we need it. Our utility pressure control module. I ask that the first time you go out on the aircraft to pre-flight it, try to identify where the 8 and 9 drive shaft is in the aft pylon area. That would be the 8 and 9 drive shaft on my slide here, because Tom and I reference that a lot when we start talking about some of the components. If I was standing in the back of the aircraft, facing towards the back of the aircraft, 8 and 9, standing underneath the 8 and 9 drive shaft, I look up to the right-hand side, that will be my pressure control module. There are 5 solenoid valves on the top of that pressure control module. Those 5 solenoid valves allow me to control the flow of fluid out of this, from the pump to all the systems that it needs to go to. So this gives me the ability that if I have a leak in flight in certain areas, I can start isolating those leaks and continue my mission. But we've modularized everything, and it allows us to control those a little bit better. And those are some of the components that it controls the fluid flow to. On the opposite side of that, still standing underneath the 8 and 9 drive shaft, look over to the left-hand side, is our return control module. After the fluid goes to all the components that it needs to go to, this is the collection point where it gets filtered again prior to going back into our reservoir, waiting to be used again. What I need for you to start learning as we go through these classes, because people are going to ask you, there are 3 filter buttons on this return module. On the bottom, there's a filter button telling me when the filter gets clogged. This little button here that I can point to on my slide, that's a pump fault button. That's for my APU pump, that motor pump on front of the APU that I talked about. If it starts to go bad, this button will pop, illuminating the light on my maintenance panel, and then I have an emergency procedure for that. And one that we can't see that's tied in behind these lines is another filter button, or it's a button, but it's another pump fault button. It's for my utility hydraulic pump. If it starts to fail, it will illuminate a light, and then emergency procedure from there. Again, if those things pop telling me that the pump's about to fail, it could be 5 minutes, it could be 5 years. We had our reservoir up top. That was to store all our hydraulic fluid for use that we needed in the utility hydraulic system, we thought. This little thing on top of the return control module, you will be asked about because it can be seen. It's called a transfer cylinder. It really doesn't hold but about a quart of hydraulic fluid, but it was kind of an afterthought. You'll notice that when you go out and you pre-flight the ramp area, you'll look on either side of the ramp actuating cylinders. They are huge, and they require a lot of hydraulic fluid to operate. When I bring the ramp down, those cylinders need to be full of hydraulic fluid. So this transfer cylinder was put in there to allow us to have a little bit more hydraulic fluid for ramp operations. Our APU start accumulator. And there will probably be several slang words out there for it. I've heard it called the bomb. Don't know if that's really politically correct in today's world. But it's located at station 555 in the ramp area. You go out, underneath the aft transmission there are 2 panels that fold down and back. And most of the time when you go to pre-flight, those panels should be open. This is inside on the number 2 engine side. This stores the hydraulic fluid needed for APU start, the pressure and the fluid needed for APU start. In flight, if I need my APU for an emergency and it does not crank, the pressure 3,000 psi of fluid that I've got stored in there can also be used to operate some of the subsystems during an emergency. You, as a pilot, may want to use some of the stored pressure there during pre-flight. So you go out, you need to pre-flight the ramp area, you need to look up a little bit higher, so we need to raise the ramp. Without starting the APU, we can use the stored pressure in there to raise the ramp. I will show you when we go through the utility hydraulics class how to do that. APU start module, located on the number 2 engine side on the inside of the aircraft, station 584. This is kind of the governor, the brains that tells that APU motor pump when to be a pump and when to be a motor. It works in conjunction with the little electronic sequencing unit for the APU. The signals tell that, again, go tell that motor when to be a pump and when to be a motor. APU motor pump, located on front of the APU. This produces 3,350 psi of pressure. This is the only pump in the system that will produce that much pressure. We need 3,350 psi, you will see as we go through our engine class, to start our engines. So once we get the APU online, we do our ground checks, control checks, and we start our engines. Utility hydraulic pressure, utility hydraulic pump takes over. We use it, everything else will operate off 3,000. Keeping in mind that when we're flying along and I have an engine failure in flight, if I need to restart it, I have to start the APU because it's the only thing that gives me the 3,350 to restart that engine. Utility hydraulic pump, located on what side of the aft transmission?
Right, number 2 side.
Number 2 side of the aft transmission. It will produce 3,000 psi of pressure for me. It will constantly produce 3,000 psi of pressure with a variable flow rate of 0 to 16.5 gallons per minute. Again, once we get in flight, there's not any subsystems off the utility system you're going to need. But you want that 3,000 psi of pressure there in case you need it. So it's always there, but just a variable flow rate. When we go through the utility hydraulics class, I've got one taken apart, and I will show you how that is accomplished. Hand pump. Oh goodness. In the Chinook world, ye who dumps pumps. If you accidentally dump all the pressure that we had stored in that APU start accumulator, this is how it gets back in there. It's a double action pump, meaning every time I pump on it, the pressure is going either way. I'm pushing hydraulic fluid inside that big black accumulator, APU start accumulator, with that hand pump. Sometimes we accidentally shut the APU off. That APU start switch up front is spring loaded back to the run position. And when you go to start, if you pull your finger through it, it will go back through that run and back to off. If that APU does not reach 90% speed, it will not recharge that large accumulator. Thus, somebody's going to have to get back here and pump this. Hopefully, that won't happen too many times. It'll wear a crew member out. Our fill module, located in the ramp area just a little bit aft of the hand pump. I'd say within a year and a half of the Delta model being introduced into the system, this was not on the Charlie models, B's or C's. Within a year and a half of this being introduced, this paid for itself. Task force went down to South America. On the way back across the water, way out across the water, to the point of no return, they developed a hydraulic leak. This allows you to service the hydraulic system in flight or on the ground. Being the crew members they had plenty of extra fluid on board. They pumped all the hydraulic fluid because that's what goes in there is hydraulic fluid. They ran out of hydraulic fluid. Unfortunately, had to start mixing oils, transmission oil and engine oil, put it in there. They were to the point where they were running out, almost ready to do bad things. And they hit land, but it did pay for itself. So remember, we can service this in flight or on the ground. This is on the bottom so that we can get to it, but all our reservoirs are up top. It will pump the fluid to the needed reservoir it needs to go to. Any questions about the utility system? Our flight control hydraulic system. It consists of some upper dual boost actuators, power transfer units, another pump, power control unit. We'll talk about some of these systems. Our upper dual boost actuators, no matter what control input we put into the aircraft, whether it be with a cyclic stick, with our pedals, with the thrust, some kind of a movement will go to our upper dual boost actuators. They are mounted up in the forward transmission area and the aft transmission area with their swash plates. They are two different kinds. There is a swiveling and there is a pivoting actuator. And you're going to be required to be able to identify which is which. The pivoting, if you look at it on one side of it, no matter which way you look at it, one of the ears should form a P. P for pivoting. Swiveling will have a bolt going through the middle so it can swivel back and forth. One's on the opposite side of the other. They'll count their pivoting and swiveling movements prevent any kind of lockup of the swash plate up top. Another easy way to remember it is which side does the pilot sit on in an Army aircraft? On the right-hand side. So in the pilot side up front, pilot sits on the right-hand side, right above him, the pivoting actuator. In the back, it's opposite. P for pilot, P for pivoting. They have jam indicator buttons on the top of them. You'll be looking for those during pre-flight. They're just like filter buttons. They can be reset, cycle the controls. If they stay in, they're good to go. And they also operate off 3,000 psi of pressure. As you can see, they control the movements of the swash plate. One side of that actuator is the number 1 system, one side is number 2 system. Should a system fail, never fear, that 3,000 psi of pressure on that opposite piston will drive that actuator. Power transfer units. I've told you that there is a flight boost pump on the forward transmission, there's a flight boost pump on the aft transmission. When you start the aircraft, those pumps are not pumping for you to move the flight controls. So with the utility system, I can make these pumps. On the utility side, I have a motor. Once I get the utility APU motor online, it will produce pressure through the back side of this motor, turning another pump, power transfer unit, for our flight controls. I have one in the aft pylon area, one in the forward pylon area, one for the number 1 flight boost system, one for the number 2 flight boost system. When you go out and you crank the aircraft up, you do your flight controls check. These are the pumps that you're using to do your flight controls check and to get your engine started. These are also backup pumps. If those flight boost pumps fail on the transmissions, then I have 2 more backup pumps. So again, there we go, start talking about redundancy. If I lose all 4 of those flight boost pumps, I shouldn't have got out of bed that morning. I mean, that's a lot of redundancy there. We'll talk about those when we go through our flight control class, break those down and show you how they operate. And the flight control system, we call our control a power control module. What they have done is they have taken the pressure control module and the return control module that we had in the utility system, they've combined them. We do not have all those solenoid valves on top of this one because we can't isolate this system like we could the other system. So they've combined them. Our pressure filter, return filter is there on these. The number 1 is located in the forward pylon area. The number 2 is located in the aft pylon area. They also have filter buttons on them and they have pump fault buttons on them. This is a good picture to show you the number 1 flight boost system in a nutshell. There's the reservoir for the number 1 flight boost reservoir, or for the flight boost system. From the reservoir during our engine starts, fluid will go to our PTUs, power transfer units. From our power transfer units, it will go to our power control modules and then be distributed out to wherever it needs to go. But our flight control systems do not have a lot of components. They operate a lot of components, but that's pretty much a flight control system in a nutshell. Pumps, forward transmission, I've already told you where that was at. Number 2 is on the number 1 side of the aft transmission. Again, like the utility pump, this produces 3,000 psi of pressure constantly with a variable flow rate of 0 to 16.5 gallons per minute at 100% rotor. A pump is a pump is a pump. All 3 of the pumps, both flight boost pumps and the utility pump, are the same pump. If I look them up in the parts manual, they all have the same part number, they have the same stock number. It's just a matter of where they're mounted and what lines are hooked up to them. Our hydraulic panel on the overhead console switch. As you start looking through your -10, they're going to refer to something as called an isolation switch. There's nothing on that panel called an isolation switch. What they are talking about is once we develop a leak in the utility system, is the ability to isolate something. If my power steering leaks, I can either flip this switch up and disable the power steering right there, or I can reach down on my center console and just turn off the power steering. Because you're going to find out when we go through class that that one switch right there will actually disable 3 systems. I got power steering, swivel locks, and brakes on this switch. But if I can isolate it just by turning my power steering switch off, I've isolated that system. I can control the flow of fluid to my ramp. I can turn it off or I can turn it on. My power transfer units, since they operate off of the utility system, if one of those start to leak, I can turn it off. But again, there is nothing on there that's marked isolation switch, just the ability to isolate something. Now we're going to start getting into our flight control closet. Any questions about flight controls? Hydraulics, flight control hydraulics. This is a little bitty part, but it has a big name. Lower control pressure control module. We'll start talking about our AFCS here in a little while. We'll find out that, or in the next couple of days, Tom will give you a good class on AFCS. You'll find out that we want our AFCS computers to always be on. They want to always know what the aircraft, the attitude of the aircraft is, and which direction it's heading. When I reach in there and I turn off my AFCS, I am turning off hydraulic pressure at the lower control pressure control module. These are located inside the flight control closet. And again, this will be part of my class to tell you how these work and what operates them. Also, you're going to find out that everything in the flight control closet operates off 1500 psi. This is where it gets reduced down to the 1500 psi. Upper dual boost actuators, we want 3000 psi. Flight control closet, we want 1500 psi. Our integrated lower control actuators, our ILCAs, located in the flight control closet. These are what operate off of 1500 psi. There are 2 portions of this. There is a boost side. The boost side of the extensible link, or the ILCAs, is something that we cannot control the pressure to. We want 1500 psi of pressure going there all the time. That is the boost. When you make a pilot input, that is the hydraulic boost that you get from moving the controls. The extensible link side is our AFCS side. In our pitch, our roll, and our yaw, we have an extensible link. That is our AFCS. That is where the AFCS inputs go to. You'll notice when you become the person sitting in the troop seat, if you can pull the soundproofing back and watch those extensible links, you'll never see anything in your life work as hard as those things do. They're moving up and down as fast as they can. They are taking those outside forces, the wind, the turbulence that you're going, anything that's introduced to the aircraft input-wise other than a pilot input, it's trying to dampen those out.
So it does the same thing as a SAS actuator?
Actually, if you will look at these, they are marked SAS links. Before in the Charlie models, that's what we had was a SAS system. But now then they work in conjunction with our AFCS computers, and they do a lot of things for you. Tom will have to be the one that really sells you big on this AFCS. I wish I could tell you a lot more about it. he's really knowledgeable about it. But we have 2 AFCS computers inside their avionics compartment, identical in operation. So that tells us we've got 2 separate systems. I can lose one system and it should not affect the other system. What AFCS does for us, some of the things that it does for us is pitch out attitude hold, bank angle hold. Now I know in the OH-58 and TH-67, I don't know about the Black Hawk and the Longbow. When I go into a bank turn, if I hold that cyclic over there, is it going to continue to roll over? Not for the 60s. You've got the automatic. But what about a Longbow? If I put in a little bit of cyclic, turn it over, is it going to continue to roll over? It will. And then the Chinook, well, I guess like the 60s, I can pick out the bank angle I want to and I can hold it there. And it's going to continue to go in that little circle that I've just put it in all day long until I either run out of gas or I pull it back up. It will not continue to roll over. That's one of the features it does for us. Heading hold. From the time I pick this aircraft up to a hover, it is going to hold the heading for you as long as my swivels are locked. It will hold the heading. Airspeed hold, altitude hold, and motion dampening. Those are things that it does for you. This is Cadillac. It's almost fully coupled. The gentlemen that are going to task force, you'll get one that is pretty much fully coupled. It will almost come into a hover for you. I think it will come back in and do a 50-foot hover and then go down from there. AFCS, again, some of the things that are in there. We've got a dash actuator and a pitch system that provides for pitch attitude stability, airspeed hold, and a positive stick gradient, meaning helping us that whenever we nose this thing over, try to get 160 knots out of it, the LCTs, the dash actuator, are all going to work in conjunction, level that fuselage back out for me, but it's still going to hold it at 160 knots for me. Our HSI works a little bit different than it does in some of the other aircraft. We were talking about the heading hold and some of the features that it has. Our HSI, once we get our aircraft set up and we've got a straight and level flight, if I need to change the heading, I find my little heading bug, I grab the little heading selector knob there on the bottom, I turn it, and the aircraft's going to start turning to wherever I turn my heading bug. Once you get this aircraft set up with AFCS and you start your flights, it's pretty much I can kick back and read a newspaper. But we know we all got to keep our hands on the controls and watch out what's going on out there. But it is set up with AFCS to do a lot of the things for you. Any questions about anything? I know we covered a lot today.
Where's that dash actuator at? Is it inside your Elka?
The dash actuator will be, whoops, there are your ILCAs right there. The dash actuator is going to be on the lower portion of the pitch ILCA. And that is one thing that Tom will concentrate on because that dash does a lot for you. Any other questions? What is the total flotation time for water operation?
30 minutes.
And why? Why are we?
Fuel cells.
We don't want the fuel cells to collapse. Or, yeah, well, the flotation time's, 30 minutes for drain the water out. Which transmission receives input from both engines? What is the weight restriction on the ramp on the CH-47 Delta? 300 pounds per square foot and the 3,000 on the ramp. On the inside, it's just the 300 pounds per square foot, or whatever CG allows us to get away with. What is the length of the cabin on the CH-47 Delta? Oh yeah. What is the purpose of transformer rectifiers? AC to DC. You will notice that on page, where does the practical exercise start? Page 61, there is a practical exercise. Probably page 63 is the answer. Do not look at the answers before you try to give it a valued effort on all these practical exercises. And again, I promise you, if you will take the time to listen to what we have to put out in class, Take the time to do the practical exercises. There will not be any surprises when it comes test time. We will cover it one way or the other. If we don't, you've got it on film now. If there's no questions, who did we deem the class leader in this one? You. Sir, they belong to you. We'll see you back in here at 7:30 tomorrow morning.